not talking about something that makes sense.
Okay, so do you know what I mean now?
I do know what you mean now.
Well,
but what's
what else
that got to do with the
that was
Cavendish
different?
experiment? That's got nothing to do with the Cavendish experiment.
You weren't even in here when we were talking about the part
Yes, I
before.
was.
You loaded in after that part.
Paul, that was
Okay.
a sidebar that I had taken on, and I had said that if you wanted to prove that static electricity existed and could be measured and stuff, is that you could take a ball that had static on it, put it in water, and then the effects that you feel, the ones that you notice, like where it attracts your hair or on your arm and stuff like that, is now gone.
I was in here for that. I heard all that.
Moyok, the issue is, mate, is that they think that like I'm somehow debating you when actually that's not really the case. I'm actually trying to understand it on your at the level you claim to understand it, and maybe remove it away from Cavendish for a moment, right? And then I'm explaining the problems that I have with it, right? And that's why I'm asking to see, obviously some form of a charted out. Because everyone says they've done the Cavendish, right? I've done the Cavendish experiment. Great, cool. So, what I want to see is that someone has, they're different subsets, right? They have certain sets of mass, okay? They either look at a different Cavendish experiment that has done something similar. They make some form of prediction about, the accelerational rate of those two mass balls toward one another, okay? To their meeting point, right? How long that's going to take based on the accelerational rate, right? Due to the obviously, if it's a larger mass, the acceleration is going to increase. And I just want to see if there is some form of consistency in the data. That is all. I want to know if there's that would be more convincing to me if someone could, you know what I mean, do it like 3 times in a row with, let's say, 10 sets of mass. And they could predict, you get what I'm trying to say?
I did give the mic to Paul, so if he wants to see for 1 second, and then I'm going to be out. I'm not going to talk anymore.
Sure.
But the modern Cavendish experiments that are done have an accuracy down into the 10 decimal places, 20 decimal places. I don't know the number, but they have a phenomenally accurate, repeatable, and it's not like the ones that you do in your high school with bowling balls in an uncontrolled environment. They have extreme accuracy.
Yeah, they're quite expensive.
They absolutely do, Moya. They have very good accuracy now.
Yeah,
as well as that, I think this guy is discounting the fact that Cavendish did use different masses. He actually did use different masses. He used different radiuses of balls. Not finished yet. He used different masses of balls. He used different materials.
It was false.
He used different materials which also weighed different amounts. Okay?
Yes.
So he did use different masses. He did use different radiuses.
Did I say
of balls.
he didn't?
You said that you wanted to see him.
Shut up.
No, why are you interrupting me?
Because you're lying.
You asked me a question, and then when I try to answer it, you interrupt me.
I didn't ask you a question.
You did so. You said, "Did I say that?" And I was trying to answer that, and then you interrupted me.
I said, "Did I say that?" No.
Yeah, and then I tried to answer that question, and you wouldn't let me.
You just stated what I said, apparently, beforehand. And I said, "Did I say?" You just stated.
Did I say that?
No. You just told me what I said, and I said, "Whoa! Did I actually say that?" No, I didn't. You don't need to tell me what I said again that I didn't say. That's why I said.
You know what I
Why
was
would I
going to
let
say?
you finish a fallacious statement, brother? Why would I let you carry on strawmanning me? Why would I let you do that?
I don't know what I was going to say.
I heard the beginning of what you said. And
you heard the beginning. You didn't hear the whole lot.
Oh, right. But it started off on a faulty premise.
To interrupt, weren't you?
He discounted that, Cavendish used different weights. No, I didn't discount that, actually. Did I? Did I do that? No.
How about you let me say what I was going to say? Are you willing to do that?
Not if you're going to start off with a faulty premise.
Oh, so you're not going to let me have my say?
Mate,
what an arsehole.
I told you I didn't say that, though, did I? So stop changing what I'm saying.
You said, what you claimed was that you wanted to see someone using different mass and to look at different accelerations.
I want to see the chart. That's what I said. I know Cavendish used different masses, okay? I said I want to see a chart, right, that shows the accelerational rates, okay, right? And then I want to see it done, and I want to see it done again. That's why I used the term like in a circuit, okay, where you start at one point, you finish, okay, and then you do the same thing again, right? That's what I actually stated. But apparently I shouldn't have used that word according to you. So obviously when I'm talking to you, I don't really know how to speak. Con the space fruitier, Tyria, or whatever the fuck your name is. The point is you strawman that point into saying, listen, you strawman that point into saying that basically, you know, I said that Cavendish didn't use different masses. No, I didn't say that. I'm saying his data to me is not.
You're actually strawmanning me now, because why do you need a chart? Why do you need a chart? Cavendish did repeated measurements. That's how you attain accuracy. You don't do it by making a chart. You do repeated observations, which Cavendish did. He used repeated observations with different masses and different materials and different sized balls of the same material. That's how you get accuracy, not by making a chart.
Mate, the chart would be based on that, those parts of that experiment. The chart would be the data from that, right? And then I'm saying you record that data and then you do it again and then see if this effect is something that is a constant, if the acceleration is constant, right? Basically, you see if it's always consistent. And I'm stating that for me, Cavendish, his data isn't conclusive enough for me to state that the effect can be prescribed to a form of mass attracting mass. Okay?
That's absurd.
That's absurd, because that's literally that is literally what Cavendish did. He did repeated measurements. He got consistency.
No, he didn't.
In your opinion, but that's not true, my friend. In your opinion, which doesn't really count here, because he did get consistency.
If you're an echo chamber, why would it matter? My opinion wouldn't matter in an echo chamber, would it? Of course it doesn't.
You're going to have to show a reason why you think it's not why it's not consistent.
Mate, the guy failed with his own contraption like a multitude of times, mate.
So he succeeded in the end, didn't he?
Did he? Did he exclude for electrostatic properties?
Going to come down to that one now. Well, maybe you should read the thing that I'm about to post to you in the chat.
Where are you posting this, mate?
Right, I did actually post it to you, mentioned it to you before, which you obviously didn't see, but other Cavendish experiments have been done that do take into account electrostatics. So don't ever say that electrostatics weren't taken into account.
Mate, we were talking directly about Cavendish and you said it is enough, and you said it is accurate enough, right? So yes, I was talking directly about that, so don't refer to somebody else to reaffirm the last statement you said. Cool, someone else accounted for electrostatics. Did I ask that? No. You were saying, how is it not good enough for you? Cavendish's rendition of his own experiment, right? Okay? That was what my problem was with it. Okay? I don't believe the data was done in a proper fashion, in a circuit fashion that showed a consistent piece of data the next time to the next, where it was the same every time. That's just my opinion on that. Like you said, cool, it doesn't matter because you're in an echo chamber. Again, I said electrostatics, how do they... Mate, you just change the goalpost, right? That's what you deal with it.
Not at all. I have told you. Can you give me a chance to respond now, please?
That tactic was obvious, right? Mate.
Instead of repeating yourself over and over and over again, give me a chance to respond. Okay. Yes, Cavendish did do repeated measurements to ensure that he got consistency. That's why he did repeated measurements.
And then you told me, don't you dare say that they didn't exclude for the electrostatics because someone else did it. Do you see how you were strawmanning me?
Can you demonstrate that he didn't account for that?
Yeah, it would be in the fucking. Are you serious? It would literally be inside of the paper. It would show how he done that. When you are doing an experiment, mate, what do? You write down the things that you do within the experiment. You know how you manipulate the dependent variable, right? How you do these different things. It's that simple, mate. If there is nothing written down that states how he did, let's say, exclude for electrostatics, then he obviously didn't exclude for electrostatics.
That's an assumption made on. That's an assumption.
That's an assumption. But then he didn't stick to the scientific method, did he?
Can I say something? That's an assumption made on your behalf. No, you are assuming that he didn't take them into account just because he didn't say so. Right,
mate,
Cavendish was a very good experiment. Cavendish was a very good experimentalist. There's no reason to think that he didn't take those things into account.
So good that he excluded for electrostatics, but didn't write it down. You're a fucking idiot.
Well, you're an idiot for assuming that he didn't.
Assuming he didn't, dude. Do you not hear what I said? If you're a scientist, right, and you're doing an experiment, what is very important that you do in your processes? So if he's excluding for electrostatics using processes to do so, you are so intellectually dishonest. It's unreal. You know yourself.
Because we provided you another guy.
Shut the fuck up. Shut the fuck up. You fucking idiot.
Why do you have to?
Right. It's a one-on-one, you fucking idiot. That's why. So you're interrupting me to tell me something, right? When it's a one-on-one, apparently. So why are you fucking speaking? That's why I'm speaking to you like that. Shut. I'll be obnoxious as I want, Con.
You'll be obnoxious, but if anyone else gets obnoxious to you, you'll cry, right?
Oh, no, you started it, so I can be the most obnoxious.
Did you give a monologue before? Didn't you give a monologue before about people coming in and attacking people and saying bad things about them? Yeah?
Well, I obviously gave up, didn't I? Because guess what? You guys just continue.
So what you're saying is that you're no better than the people you claimed were being obnoxious to you.
Mate, you sort of get what you're given in life. You do know that, right?
Oh, well, then we're even then, hey? So why are you crying about it?
I'm not. You are. You're the one complaining about it right now.
You're being a little bit of a prick now because he also gave you another guy who done the experiment and he took into account the electrical forces. So what's your argument now that the Cavendish experiment is invalid or the gravity is invalid depending on our own experiments?
It doesn't actually prove gravity at all, let's face it, guys. Come on.
Oh my god, that's stupidity.
That's what you wear.
So now you're being intellectually dishonest by claiming that we can prove gravity.
Yeah, you know you can't prove gravity.
That's why are you interrupting me? Why are you interrupting me? Right? Are you scared or something? Right?
Yeah.
Science doesn't ever claim to prove anything, dude.
All right. So the Cavendish experiment is that right? The Cavendish experiment doesn't prove gravity. Thank you.
Science doesn't prove anything. Don't you know anything about science?
It shows cause and effect relationships. I understand.
Science collects evidence. It collects evidence in support of hypotheses.
No. Science is to show cause and effect.
No, that's not true. Right. It can show correlational relationships too.
Oh, can't it? Yeah. All right. Cool. Thanks. I won, I guess.
No, you didn't.
Yeah, well, my premise is that gravity isn't proven by the Cavendish. You just admitted that. Thank you. Cheers.
Well, look in the chat. If you'd be so kind, look in the chat, Crackvillan.
Why would you have a premise like that?
Yeah, he changed the materials with different electrostatic properties. All of them inherently have electrostatic properties. That's the point. Right. But don't try and tell me that he used a modus operandi to limit and negate. That was my claim, that he got rid of.
Read the second half.
I have.
Okay, the second half is that regardless of what he did,
So they all had
still today bears
electrostatic
out
properties.
even when they do account.
So could that be something to do? Could that be something to do with the causation? Maybe.
No.
Electrostatics were not a problem. No, you just claim it's mass attracting mass.
We can measure static. There's no question that we can measure static.
All right.
We use it for things.
Anyway, like I said, I'm yet to see someone do a very good Cavendish experiment.
If I'm not mistaken, the best one that I've seen done was by B.M. Furballs, and he kept on trying to deal with all the flat Earth stuff. So I'm pretty sure that he actually accounted for the electrostatics with a common ground. I'm not positive anymore.
You link me that would be great, mate. Honestly, because I'm not actually here to be like an actual wanker. That's why I'm speaking to you normally, bro. Like, do you know what I mean? This guy Con or whatever, he just from the very first second he spoke to me, he had a tone in his voice. Because I'm a flat earther, it's like you're a fucking dick, basically.
No, it's not because you're a flat earther. It's because you're saying stuff that's stupid.
You're biased, mate. You're biased.
I'm not.
Come on,
not biased at all.
You are,
when
mate.
you say stuff that's stupid, I'm going to call you out for it.
Also,
all right,
most
mate.
of that tone
You
is
didn't.
Australian.
Because I'm Australian.
No, he is.
Yeah, I am. And it's not as if Cavendish is the only experiment that demonstrates mass attracting mass. And it's not as if that Henry Cavendish was the only one that ever performed this experiment. It's been done by thousands of people over hundreds of years, and all show the same thing. That's consistency.
Did you say over thousands of years?
No, I said hundreds. Listen carefully. I said thousands of people over hundreds of years.
You sure?
I'm absolutely positive.
Don't worry, I'm just fucking, mate. Yeah. Cool, mate. But it still doesn't prove gravity, though, no?
It doesn't.
So
and that's not a claim that anyone would make.
All right. Cool,
There you
mate.
go. Here's the Verbal. There is a bunch of videos associated with this, but so you might have to find the one that most.
Can you DM it to me?
I will. Now I'm going to put it in chat.
Cheers, mate.
I was going to say is just go through this. You can watch the video, but you can dig through all his videos to see how we. There's probably 30 hours of videos.
Yeah, no, I will check it out. I will check it out, 100%. But yeah, realistically, we just don't really observe mass being attracted to mass, on a regular basis, right? You basically, the point is you have to build things up onto onto balance bars, and you have to add, weights on there, that essentially the issue is here, right? Is that this isn't something that we just naturally observe, right? The reason why.
We do observe it. Absolutely.
You observe it.
It was to measure the constant for the relationship between the force and how much mass is applied.
There's also about 90 different. There's about 90 different experiments that Gem Panda has posted that support this.
That's fine.
I can't find. There's a PDF that shows a list of all of them.
Yeah. Okay, but gravity is obviously described as something that is affecting the natural world, right? The one we live in. Okay.
Right. Yeah, we see its effects. We see shit fall down. We see air fall down. We see everything fall down.
Yeah.
So after that, we had to now try and isolate that effect. Hence, we come up with these sensitive tests because it's hard to isolate it while you're in a field.
Because down isn't an objective direction, right? Because how could it be on a ball, right?
How can I say objective direction? What does that mean?
Well, okay, sorry if I used the wrong term for you, my friend. Well, down being down.
Sound is objective. It's just not universal, I think, is where you're going.
Of course, obviously, if you're on a ball, right, then you can't really have a true down, right?
Where you are, you certainly can.
Oh yeah, where you are, yeah, of course.
Everywhere else.
Well, I'm just saying you need a force such as gravity, right, in order to explain how you can have down all the way across the face of a spherical ball.
We see a force. It's not a question of whether we assert one. We see one. We know that something's accelerating. If it accelerates, if something accelerates, it is a force. That's by definition.
Yeah, but gravity has a lot more effects ascribed to it, right?
I don't know. That's the biggest one.
Not really.
We see it. We see the attraction of things together in an accelerating force, which has been somewhat disproven by Einstein, or not somewhat, but when you get deeper into it, you find out that it doesn't work quite how we.
The new hotness, the warping and bending of space-time.
Right, but still, is the same. No change to the effect.
Still the same. So something's disproven by Einstein, but not really. This is what I mean. It just seems not very concrete, considering there is still no real, scientific proof for gravity, right?
Sure.
I don't know.
If you mean scientific proof, as in mountains of confirming evidence.
No, don't mean that.
Repeatable confirming evidence from the Schehalian experiment to Cavendish to the 9 other experiments that I can't cite because we don't use them very often.
You're presupposing the cause. Presupposing the cause.
Gravimeters are actually quite a one elegant proof. Because and it's one that's used on gravimeters. They're very sensitive gravity meters that they use to find underground deposits of dense materials or varying density materials. That's when you get down to the fine measurements. It's like, now you can go and find out that there's iron ore below you. You can find out there's a lead deposit. You can find uranium, oil.
How exactly? How exactly does the machine what? Oh, sorry, dude.
Yeah. If you want to get into the weeds about what Einstein predicted about gravity, you have frame dragging, which is a kind of an exotic effect that no one had ever observed. So they built the Gravity Probe B experiment, which was 2 satellites, and they measured something that had never been before measured and never been before predicted except by gravity.
Right.
Pretty compelling stuff.
Sure
Which
is.
Was what?
And there's also the Gaia satellite.
That gets into the weeds of relativity, so I don't even want to pretend to
understand
the details.
Yeah, I get that.
And there's also the Gaia satellite, which has measured the positions of about a billion stars accurately and can demonstrate the warping of space-time around the vicinity of the sun. Have you ever whirled a stone around your head on a piece of string, Crackvillan? Have you ever whirled a stone on a piece of string around your head?
No, mate.
What? As a kid, you've never done that?
No.
Have you ever played with centrifugal force?
I know what centrifugal force is, mate.
Well, you can imagine the stone being whirled around your head and on a piece of string, can't you?
Yeah. I wouldn't do that though.
Why? Doesn't matter. You don't have to answer that question. But what keeps that stone going around in a circle?
Nothing if you do not move at all.
What do you mean?
What do you mean? What do you mean?
If you whirl a stone around your head on a piece of string, what keeps that stone going in the circle?
What do you mean what keeps it going in the circle? It's not going in the circle.
What if you're whirling it around your head in a circle? It's going in a circle.
I'm not doing that, mate. Am I? That's the point. I'm not actually doing that.
He thinks it's a trick question, bro. What a funny man.
Of course, it's not a trick question. I know it's not. I'm just not engaging with a guy that's
you're very scared. You're scared, dude.
No, someone else talk about it.
Okay, enough.
I'll talk to someone else. I'll talk to someone else.
I bet it's the string. Is it the string? I'm saying the string.
It's the string exerting a force towards the center where you're holding it, right?
Is that string?
Circle around something. There must be a force acting towards the center. I wonder what
static
string.
Static electricity.
You know, it's just another example of mass attracting mass.
Electrostatics are inherently stronger than gravity, though. If we assume gravity. Distance.
They can be, but it's a lot easier to have a stronger gravitational force than a strong.
Oh, is it easier? Is it easier?
Let me finish. You just need a bunch of mass in one place to have a strong gravitational force.
Well, like the ground underneath.
It takes a lot of effort to build up a strong static charge, and they tend to dissipate pretty easily.
So, like the ground underneath me, right? There's a big mass.
That's certainly one example.
Yeah.
What static charge would you need to actually hold the moon in place?
But I'm just about to talk. I'm not saying static charges hold things like the moon in place, right? Am I saying that? We established earlier that electrostatics are something that when something is electrically statically charged, for instance, that it is localized to the area that it's in close proximity to, right? Okay, so its range. I'm not claiming it has a range like you guys are claiming a range with gravity that is to a ridiculous degree that no one can actually prove. But again, electrostatics, for instance, if I blow up a balloon with my mouth, so it's just basically what I'm breathing into it, the balloon that I've blown up will fall to the ground. Okay, let's say that's because of gravity, right? We'll say that's gravity. That balloon, if I rub it on my head, obviously I've charged it electrically with static electric. Okay,
it'll fall
I'll
the
stick
same
it
rate.
to my chest. I'll stick it to my chest. It ceases to fall to the ground. The electrostatic charge at that point is stronger than the force exerted on that balloon. A balloon that would, however, fall to the ground, right? But listen, we can displace this electrically static charged balloon. You know, if you don't charge it too much, so like, you know, don't impart too much electrostatic into this balloon. So just rub it a little bit on yourself and stick it to your chest. You can put.
Isn't there a number that we could actually come up with, like the amount of static charge? I mean, I can measure the static charge, and I don't.
Yeah,
personally, I don't.
You can measure it, but
you can measure it and say, okay, it takes 50,000 volts to stick it to the wall, and it takes 100,000 volts to stick it to the ceiling and make it stay on the ceiling. Now, that would imply that there's a certain amount of force to overcome gravity with the friction and everything that I know how much I can achieve. So I need to know that in order for those balls to attract each other at the rate of gravity does, there would have to be an amount of charge. And we can test for that charge to see whether it has the 100 volts necessary to be the equivalent of the effect that we're seeing. Now we measure and we see it doesn't have that 100 volts. Now we know that that's not the cause, right?
Right. I wasn't finishing what I was saying, and it probably would have helped what you were saying. But again, so like this is stuck to my chest, right? Okay. And when I said that you don't charge it too much, I just sort of meant don't rub it on your fucking head forever, right, guys? That's what I sort of meant. You stick it to your chest, yeah. So and you can displace it with about 10 milligrams of weight, okay? So that means that a force on that of 10 milligrams downward is able to displace that weight. So the electrostatic charge being broken by just 10 milligrams of weight would incline that, to me, obviously, that the gravitational force on that balloon is so little at that time, right? It's unreal.
No,
it's a very small amount.
The exact same rate. So the gravitational force.
But I wonder, roughly, if we were to weigh the gas particles around this balloon, right? Roughly what they would weigh.
Also could be done with a good calibrated scale. You go and take your balloon and you stick it to the wall of your scale. Basically,
not the balloon. The gas
got a box
around, not the balloon.
You've got a box sitting on your balloon. Balloon on it, and you're going to see if there's the same amount of weight as when you're dropping it in free space.
Listen, I know how to weigh the gas in the room instead of the balloon, so I'll just stick the balloon on an upside down scale instead.
Sure.
Hook an eye system, tear the scale, and then have. Again, the issue with this is that the resistance of the actual scale itself with the balloon, it might not even register, right? Because of it. Well, it would if it's extremely sensitive, right? So it's trying to fall down. Okay, we could say if this weighs going downward, we tear the balloon, like I said, we account for the gas inside of the balloon. That downward force, you could try and attribute that to gravity, but I would say that would probably be more likely the gases around it that are pushing it down due to its relative density. Okay.
How can you have relative density without gravity?
Pardon?
How would you have relative density and density without gravity effect?
Well, you would still have relative density. It just wouldn't do anything without gravity.
It just wouldn't do anything.
Yeah.
Yeah.
Because everything would fly upward without gravity, right?
No, it wouldn't do anything.
It just wouldn't do anything. So if we get rid of gravity right now, just nothing happens.
Essentially.
Well, things would bounce up because they're under pressure from being in gravity, but we're assuming that there's no gravity to begin with in that idea.
I build a cityscape inside the ISS. If I build a cityscape in the ISS made of lead, and I put a little object above it, it'll slowly move towards the lead, but it essentially will float.
Have you ever heard of a guy called Robert?
Honestly, guys, I'll be honest.
Have you ever heard of a guy called Robert Millikan?
Wow.
Well, that's a simple question. Have you heard of a guy called Robert Millikan? You can say no.
No, I haven't heard of him.
Okay.
I thought I already said no. Sorry.
Yeah. Well, I didn't hear. So Robert Millikan was a physicist who did a pretty famous experiment to determine the fundamental charge on an electron, right? The unit of fundamental charge. And he did this by statically charging oil drops and balancing that static charge, the electric field, and balanced that, the mass of the oil drop with that static electric field, right? So he balanced the force of gravity with an electric force upwards, and he was able to determine the fundamental charge on the electron, which we know and we can measure by other means nowadays too. Okay, so how was he able to do that experiment if gravity wasn't a thing?
Well, this is the first I've heard about the experiment, mate, so I'm not going to make a comment on that right away, am I?
Yeah, it's just an interesting experiment you might want to go and have a look at.
Yeah, no, I'll have a look at it.
Familiarise yourself.
I'll have a look on it, but I'm not... I'm not going to make a comment on something I know nothing about.
I understand that. But that's just another demonstration of how we can actually use static charge to measure something, balancing it against gravity.
I'm sure. Can you send that little bit of information to me then?
All you need to do is look up Robert Millikan, and you'll find out his experiment. You could do a little bit of research yourself, eh?
What's the name of it? What's the name of it? The experiment?
Well, if you just look up Robert Millikan on Wikipedia or anything, just type it into Google, you'll find him.
You can just say if you don't know.
Oil drop.
I'm sorry, Paul. Is static and magnetism on a cube function rather than a square function?
No, it depends on how you're talking about it. If you're just looking at a static charge, if you're just looking at a static charge, it's the same thing as the gravitational field. It's a inverse square relationship, right? But if you're talking about dipole fields, like if you're talking about a combination of charged particles together, then the roll-off is different. So you can imagine that the Earth's just not negatively charged, right? It's overall neutral. It has to be, because the solar wind contains both positive and negative particles, right? So if the Earth was to gain a net positive charge, it would repel the positive parts of the solar wind and attract the negative ones until it was neutral, and the other way around as well. And so you just can't build up a large charge on the Earth overall.
Isn't lightning a way that the Earth moves charges around?
Sure is.
Right, wait there. So what's his name again? No, like verbatim.
Robert Millikan. M-I...
Yeah,
I don't know whether that's double L. M-I-L-I-K-A-N.
Millikan? Is he Scottish? Moyuk. I just sent it to Moyuk in like a name just so I could save it for later. So if that doesn't make sense, Moyuk, it's because it's with someone else that I wanted to look at. You sent me. So even that's not a proof of gravity, right?
Evidence of.
Going on about proof. Did you forget everything that people said earlier?
I'm not forgetting nothing, mate.
Then why'd you bring it up again?
It was a question.
I know that, but why'd you say it again?
Well, the thing is, right? Listen, mate.
Evidence of, or strong evidence for?
The difference.
Then it is.
The difference is like when I speak to other people, they'll instantly say like, yeah, no, gravity is 100% verified and all this sort of stuff, right? So the difference is you guys have got a different approach. So I'm like, and then you're bringing up other points. So I'm like, okay, you're bringing up another point to do with gravity, and then you state how would something be possible without it? And then you're saying, well, yeah, but we don't actually know whether it does actually exist, okay? So there's just an inherent contradiction within that.
No,
that's all in my mind. That's not gelling. So I'm asking again. I'm asking again because
gravity is a thing because we have solid justification for it.
I
want absolutely say 100% that we're correct about it. No.
I want Crackvillan to explain a little bit more. Where's the contradiction?
Pardon?
You utter shit when you speak. Tell me, where's the contradiction?
Oh, well, the contradiction is saying that, you cannot have relative density without gravity. Yeah, relative density is something we
haven't explained.
Someone did say, listen, this is what I'm talking about, the contradiction. This is the contradiction I'm talking about, nice guy. Right? This is the contradiction. So don't tell me I'm not talking about it when I am. Somebody stated in this room that how would relative density work without gravity? Okay? And I'm saying, when someone is saying to me that, well, gravity might not be 100% true, we don't necessarily fully know whether it's validated or not, right? That's cool. I'm fine with you guys saying that. I'm actually happy you're saying that, all right? That's brilliant. That's called intellectual honesty. That's brilliant. But I'm saying it doesn't... Wait, I'm not finished. It doesn't gel well, obviously, because the thing is with relative density is that we basically know that it exists, okay? Regardless of what paradigm you want to put it in, whether you want to look at it from your perspective of how it works, or whether you want to see it from a flat Earth perspective, okay? We can show how this works, right? We can do so in a way that is verifiable, and we can repeat this time and time again, okay? So basically the point is regardless of whether gravity exists or not, relative density still is a thing that works. So that's the contradiction in my head. So for you guys, let's say we disprove gravity tomorrow, so relative density just goes out the fucking window.
All right, wait a minute.
That is my response. That's the contradiction.
Wait a minute. this gets into a little bit of semantics, and people will disagree on the exact wording. But
yeah,
if you want to get into it this way, then we know absolutely that gravity exists, and we know a lot about how it works. Gravity is the name for the thing we observe, that things fall, and we observe that things fall towards other things with mass. The thing that we're not absolutely sure about,
do we observe them?
Let me finish. Let me finish. The thing that we can't say 100% on is exactly why and exactly how. That's where you get into the specific theories of gravity, like Newton's that we know was not entirely correct, or Einstein's, which we also know is not entirely complete either. But they're both very, very accurate, and we know that the thing that they're trying to describe is a real thing.
It is a real thing. That's the point. It is a real thing. It is a fact. It is an apparent force that we can see and observe and measure. But the underlying functioning, the mechanics of gravity, like the things that makes gravity, those are the things that we haven't yet discovered or studied, deeply enough as someone like me. And even the frontier in science, we haven't yet established, like some people say, gauge theory for gravity. Those things haven't been yet released or established yet.
Yeah.
So yes, we don't know the fundamental mechanics of gravity, but it doesn't mean that gravity doesn't exist. And again, it's not a contradiction when I'm telling you can't have relative density, the effect of it, without gravity. Because let's talk about density. What is density? It is mass over volume. Let's say it's matter over volume, an amount of matter over volume. Now you need to specify which one of those components are actually forcing things to go down and other things to go up. You're gonna go to matter. So there's a property of matter which is basically forcing things to go down and forcing other things to go up. Now, when things go down, it's because of attraction, and when a balloon of helium is going up, there's a force of buoyancy, which is the surrounding medium is much heavier than the helium itself. That's why it's actually pushing the helium up, because the surrounding is much heavier. You can't have heavier, you can't have lighter without the concept of gravity as a force. There's no contradiction. You can't have relative density, the effect of it, without gravity. Drill this in your mind.
Right. So you can assert that. It's
not an assertion, it's a fact.
It doesn't. Okay. I'm just saying you can assert that, but again, like I said, until I actually really like the way that started. Nice guy. I'll be honest. Like, it was great. You don't understand the mechanisms for it. No, there are certain agreed upon things within inside of this. Okay, Newton wasn't exactly right. That's why I have a little bit of a problem, obviously, with certain experiments that use Newtonian laws of physics, right? Because obviously certain parts of it are wrong. Certain equations have been disproven, been shown to be inaccurate, and vice versa when it comes to Einsteinian gravity.
Incredibly accurate.
It's very accurate.
Okay,
we can actually predict. We can predict the planetary movement with general relativity to a super precise accuracy. It becomes pointless to say we don't really yet understand the full mechanics of gravity. Yeah, we don't have yet a unified theory how gravity can emerge and so on and so on. But still, this is so far deep into science and the frontier of discoveries that is still irrelevant to the fact that actually the effect of gravity does exist.
Let's call it
an abstract
concept, mate. That's all. You don't understand the way it works yet. You can't call it science. You guys need to stop doing that shit. Because you're being intellectually honest anyway, though. Look, that's better, right? You don't understand exactly how it works. Cool, great. And there are agreed upon things.
Is working on figuring out how things work.
Yeah, of course, mate. But listen,
if we don't know everything, is just ridiculous.
I was talking about.
Well, you were being ridiculous.
Listen, slacker. No, I'm not being ridiculous. I was actually saying I appreciated the intellectual honesty.
Okay, so I'm gonna give you some context. Okay, I'm gonna give you some context.
No,
so when
I wanted to say something myself, mate. You just monologue for a little bit. I don't mind your monologue. It was nice, all right. But no, slacker. I'm not being ridiculous. I'm just stating, there are agreed upon things, right? There's an agreed upon average of things falling down, right? So yeah, we see that effect happens, but again, until, in my opinion, we understand the full, realm of how the effect is caused. Okay, we can't start to say it is science. Okay, but most of you guys aren't saying it's fully. You guys aren't actually claiming gravity to be something that is actually fully proven, which is not what I usually come across. So I don't really have much of a problem with it. Okay,
it's different.
What you guys are saying, I don't have much of a problem.
Again, it's totally different.
Thing is fully proven.
Yeah, that's
Science
my point.
doesn't prove anything.
Jem, that is
your
my point, bro. And that's why I don't
that until we understand everything, we can't say we understand anything. And I think
no. I said you cannot call it right. So wait there. I was saying that basically I didn't say that. So I'm not saying that. I'm saying that I'm actually glad at what Nice Guy said, because Nice Guy is being intellectually honest. He's saying that you don't understand the mechanism. He's saying you don't understand the mechanisms fully in their entirety, which cause the effects that are put under the banner of gravity, right? I'm not saying that you can't understand anything until you understand all of it. That is not what I stated. I simply stated that people claim to understand more about it than what they do. That hasn't been done here, okay? So that's not a problem. And that's all. And that basically you can't say the part you don't know about. So basically what would be the cause of the effects put under the banner of gravity. If you don't understand the cause to effect relationship, it cannot be denoted yet as science.
That's not true. That's not true. That's not true. Because we don't understand something, your definition of science is wrong. Science as a definition is not whether we understand something or not, right? Science is a way of coming to an understanding of something, right? You're saying that it's not science unless we understand it, and that's patently false.
Well, it's not following the scientific. There isn't something within the realm of the scientific method that can validate the cause and effect relationship of this thing.
The scientific method doesn't. The scientific method doesn't say that unless we understand it, it's not science, which is what you were trying to claim before.
Well, I just said, sorry, is that better for you? But you just like to just keep ramming things.
And there are plenty of experiments done using the scientific method that demonstrate gravity. You claimed before that you could make relative density work. Well, I would put it to you. If I have a lead ball with a density of, let's say 1,125 kilograms per cubic meter, and I throw that upwards at 10 meters per second in air, which has a density of about 1.2 kilograms per cubic meter, how high will it go? Can you do the calculation for me, please, if relative density works?
Mate, I don't even remember any of the numbers you said, because you said them very quickly anyway.
Okay, say them slowly then. I'll say them again slowly then.
No,
the point would be that you claim it works. You claim that you can make it work. I can do that calculation and come up with an answer quite easily. But can you do the same with relative density? Because that's what you would need to show that it works.
Is relative density a real thing, yes or no?
Yeah, it is. But it doesn't allow me to do that calculation, does it?
It's more even of a description as well.
All right.
Consequential to the measurement that he's describing.
Relative.
Yeah. I understand that he's asserting that. I get that. I know that.
You're not really asserting it. You do believe that you can do the measurement.
Sorry, fucking hell. You guys like to really pick a bones apart on words, don't you? Fucking hell, mate. I actually told you guys I wasn't actually coming here to try and actually debate anyone. It wasn't actually what I was really trying to do. I'm actually trying to find out what your opinions are on things. You're so pissed off that someone's a flat earther, and you're like, right, you can't. You're a flat earther, and it's like, right. So
I'm not attacking you because you're a flat earther. That's not true at all. That's not a claim. Right? I'm not attacking you because you're a flat earther. I'm not even claiming you're a flat earther. I'm attacking you because you said that relative density was something that you could use and that you could make it work. You claimed that it would work. And I'm pointing out to you that you can't do that. You're making a false claim.
You're trying to see who you can stir up. Like, come on, let's see real.
I've heard you say this before, Paul, and I never really paid much attention to your tossing up example, but yeah, that's quite elegant.
Yeah, because like I'm giving them the relative densities. That's what they claim, isn't it? They claim that they can make things work using relative density. So I've given them the relative densities and the velocity. They should be able to make it work. But no, you need something called, you need to know what the acceleration of gravity is to make it
I
work.
already told you that there's an agreed upon acceleration towards the ground, right? That is what I need. And that is all. Okay?
And that's a force.
I can observe this without hypothesizing a fake
And acceleration is a
magical
force.
force called gravity that you do not know the cause of, as admitted by your friends. So shut up. The calculation could be done and relative density would work. Relative density exists. You know it exists.
And do the calculation. Then do the calculation. If it can be done.
I don't need to do a calculation.
You do. You do because you're repeatedly claiming that it's possible to do it. So in order to show that it's possible to do it, you need to
if I do the calculation using what? Guess what? The agreed upon average of things accelerating downwards, right? Things at that full rate. Guess what will happen? It will work, right? That doesn't mean that I've used gravity to make it work, does it?
Yes, it does.
It means that I could no. It could mean that I basically did what? It means that I could have dropped something, okay? I could have measured how long it takes for it to hit the ground, okay? Yeah? And I could use that to put it in. I don't need to talk anything about gravity or hypothesize where gravity comes from. I don't need to talk about vector towards the center of the ball. I don't need to do any of that, my friend, okay?
Should we take the simplest explanation?
Well, it would still work. Would the calculation work, yes or no?
No, because you didn't use relative densities for that calculation. What you did was you used the acceleration due to gravity, but you just didn't call it that. You want to use the principles of gravity, but you don't want to call it gravity. That's what you want to do.
We can observe that things fall down at that average. So I don't see what your issue.
So your entire understanding, of
you can't say that.
If we were to teach children in school the flat Earth version of relative density, what we would say to them is things fall down, and that would be their entire understanding of it.
Well, yeah. So down is only a problem for you guys, right?
I'm talking about what we understand.
I know what you're talking about.
I'm talking about what we understand about relative density.
Yes, Jen.
What you're saying is the only thing we understand about it is things fall down, and that's all we need to understand about it.
Well, no, relative density doesn't just denote that. You can change the vector of something.
We need to be able to make
if it's useful, right?
If it's useful to us, we need to be able to make predictions with it, right?
Yeah,
that
cool.
would be useful. Right, so make a prediction.
Okay, I could predict that I could change the vector of something falling with relative density.
Oh, you need to quantify this.
Well, I'm saying that I could make it not just fall straight down using relative density.
Right, so you need to show how.
I could explain to you
how much you could make it deviate from its course and how you would go about doing it.
Right. So I could go about it by, let's say, I could manipulate the medium, right? So I could impart energy on one side, which would be in the form of heat. Okay, so I would excite.
You need to put some numbers to this. You need to show how you can make.
I'm explaining it conceptually first to you, right?
I don't. I need because I'm sure you can make up some bullshit. I don't deny that for a moment.
Okay,
what you need to do, what you need to listen.
I don't need to do anything.
What you need to do is make the made-up bullshit mean something when you apply
it in a conceptual mathematical language, right? Is that how everything? Is that the only way something means something to you? Is that right? Or if so even if someone could show this,
I need you to make a calculation. I need to make a calculation that predicts an event in the real world that shows how something would behave in the real world. That's all. I don't think that's much to add.
So you're asking me to ascribe a language to it of mathematics for it to be real, right?
No. So I'm just asking you to predict. I'm just asking you to predict how, say, two objects of different density would move. In either drop from a certain height or propelled to a certain height with a certain amount of force. Just show us how this works in reality. And of course you can't. You know you can't. Or you can do it. So relative density, things fall down. And that's it.
So you are denying relative density?
No.
So does it work or not, Jam?
Deny your explanation for relative
density. Can people make predictions with relative density?
I don't.
You know the nature. You do know the nature of mediums,
not the
right?
predictions. Not the predictions that we can make with gravity. No.
Why would that be, though, Jem?
Oh, okay. Show me how. Tell me how relative.
Why would it be? No, but why would there be more variation with inside of relative density with
there
what you would call calculations and predictions?
Show me. Tell me how relative density describes the orbit of the moon. Because gravity
you're presupposing that it is orbiting, mate.
Well, we see something.
See it orbiting. Could see it.
Oh, cool. Well done. You see it move in the sky. Okay.
Yeah, in an orbit around the Earth. Yes.
Yeah. Well done, mate. Yeah.
Yes.
Cool. No.
No, not no. Yes.
Yeah. No. No,
not no. Yes, that's what we see. That's what we observe. That's not. There's absolutely nothing presupposed about it. It's a conclusion drawn from observing the motion of the moon. There is no presuppositions whatsoever. Go ahead.
You're saying if you only observed the moon on its own, you knew nothing else, and you saw it move, that you wouldn't have to presuppose anything to know that it was orbiting. So you could just see the moon and know that it's orbiting, right? You wouldn't have to presuppose a force that was keeping it there without testing for that force. You wouldn't have to presuppose the fact that the Earth was what? And a shape that actually would be able to be orbited around. Are you genuinely saying there's no presupposition involved?
Yeah, there's no presupposition. You don't need to say it 5 times. Right? There is no presupposition because you don't need to know why something is. You don't need to know why something is moving to see that it is moving.
Right. It's an observation. It's not a presupposition.
Yeah. So it's moving, but that doesn't tell you that it's orbiting, though, right?
It does.
Well, you can do measurements. An orbit is when something moves in a circle around something else. So, yes, that is observed.
So it's circling around the Earth. Okay.
That's observed on the flat Earth as well, isn't it? Don't forget.
Yes,
by you calling all this into question, this is part of your narrative as well.
Orbit is
that the moon goes round in a big circle above your head, right?
You know there's more to it than that when it comes to orbits.
No, there's less to it than that, isn't there, with the flat
No,
Earth? We don't know if it's actually a moon. It might not be real.
We don't know that it's actually a moon. It's called the moon, so thus it's the moon. That's the way language works.
We don't know if it's actually a solid object. You're just presupposing that a thing that looks exactly like a solid object is a solid object.
When did I say it wasn't solid? Are you like just ramming the shit in my throat now?
Oh, you agree the moon is solid?
It looks solid, does it not?
Great. That's a step forward.
So
lots of flat earthers won't admit to that. Don't try and make out it's some weird idea that I've come up with.
But
I would say more than half.
I would say
more than half won't even admit that the moon is a solid object.
But Jem, do you know any other way of making something appear to be solid? That's the problem with that, isn't it? If they don't know the nature of what it is, for instance, right? If someone doesn't know the nature of what someone is, and if you know anything about, obviously, the way light can work, for instance, like things can appear to be obviously completely different to what they actually are, right? Apparently, when we see the moon, we're not even actually completely looking at it. Apparently, that's an apparent location of the moon, right?
Well, when I look at a mountain, I can derive from looking at it that it is a mountain and that it's made of rock and soil and things like that. Right. Well, I look at a mountain on the moon.
Yeah.
I draw the same conclusions.
Yeah. I don't have a problem with you doing that, Jem. I don't really see what the contention is.
Well, it doesn't sound like you do, because if you're agreeing that the moon is solid, then that's half the battle. But the point is, the moon is observably in an orbit, and relative density can't make predictions about that orbit, and gravity can.
That's because relative density isn't ascribed to be anything to do with the moon. Why would it make predictions about something that it has nothing to do with, Jem?
Does the moon have a density?
Does the moon have a density? What has that got to do with anything?
Well, if your theory is about relative density...
I don't know the moon's density. I don't know the moon's density. I don't know what it's made of. It appears to be solid.
Surely relative density applies to everything with density.
Yeah, he saw that one coming.
Listen.
Yeah, he did, didn't he?
Listen.
Yep.
Listen. It doesn't really matter, does it? Because where
it actually does. Relative density makes the force of the ground. So if the moon's got a density, why isn't it dropping to the ground if it's floating above the flat Earth?
Who said it's floating?
Well, that's what you guys tell us is happening. It's equidistant from the sun and the moon, opposite each other, floating around the disk of the plane of the flat Earth. So what's holding it up there, and what's holding it
I'm not making any claims about what's holding it up there. I'm not making any claims. Why would I make a claim about that? I don't know.
Oh, of course. No, typical Witsit deal. I'm not making any claims because then I can't get busted.
There's a string on the dark side.
Mate, if I don't understand something genuinely, I'm not going to claim to know it. That would be ridiculous. That would be just lying.
Okay, so why is relative density also referred to as specific gravity? Can you explain that one to me?
Well, I'm actually trying to talk to Jem a second, and I will talk to you afterwards. That's cool. Dr. Nemesis, or whatever your name is. Is it Dr. Nemesis? Yeah, it is.
That's it.
Yeah. So, yeah, Jem, so back to what we were originally actually talking about. Yeah, so orbit, there is more entailed in that word. We know it is. That word has more of a meaning now. Okay, so, and we know it does. Orbit, states that it is obviously, like you said, revolving, okay? But again, it's not just simply revolving above your head, is it, Jem? Like you said, like a circle. No, you are presupposing that it is rotating around the Earth, right?
How is that a presupposition if that's what I see?
Well,
what's the difference between seeing something happen and presupposing that something happens?
Let me explain what I was saying then. So you said you needed no presupposition in order to show that the moon was orbiting. You just observe it, right? And there's no presupposition there. Right. And I stated next, I said, okay, so you know nothing else about the world. You've seen the moon, and you don't have to presuppose anything to say that it is orbiting. And then I said, well, you would have to. You would have to presuppose that the Earth is actually a sphere.
Well, hold on. Why
you would have to well, yeah, but how is it up there, Jem? What's the modus of what is it that's keeping it there, Jem? Are you presupposing the forces of gravity? Are you presupposing?
No,
that's what I'm saying. Yeah, so
I'm not presupposing any of that. None of that is presupposed. None of it.
Well, it would be presupposed just off of base observation of the moon.
I observe it orbiting.
I observe it above my head, and I was saying nothing else.
Well, you can call that orbiting. You'd still be accurate.
No. Because that word has a different meaning than just a circle above.
It really does.
It does. If we hear the word orbit now, we think of a spherical model with something revolving around that.
That's the moon. You. But what it means is something moving in a circular path around something else.
The moon isn't the only thing we see orbiting. We see other moons orbiting around other planets.
Right.
Yeah. Cool.
We have an orbital motorway around London.
It's
called an orbital motorway.
We also know how far away the moon is, and we know what velocity it's moving with reference to the ground. And we notice that there's a correlation between the velocity of things and the distance they are away from us.
Yeah.
And that comports with gravity's explanation.
No, of course it would.
No, not of course it would.
No. Gravity is just mathematical equations that are literally, to explain things that are going on. But the issue is that it's a backward engineered language, my friend, where you have to. It will work. Listen, it works. Yeah, if you state that this thing is this distance away, if you state that it has this exact volumeric mass, even though you haven't tested any of it, you know, you haven't tested what the medium of, you know, going down, you know, toward the center of the moon. You don't know exactly what it's made of.
Don't go too far.
So listen, yeah, you basically have to presuppose lots of different things, okay, in order to state that this thing would work in congruity this way with gravity and all of this bullshit. You haven't verified any of this information for yourself, just to let you know. You really haven't.
Well, I've deduced, you know, by the fact that every inch I go up above the surface of the Earth, the pressure drops, and there's no real variation in that as an average and a whole. So as I carry that all the way up to the top of a mountain that I've been to personally, I've been at 14,000 feet without the assistance of oxygen, and I noticed that the air pressure was really low at the top of that mountain.
Yeah,
I can deduce that if I keep going up, the pressure is going to keep going down. So the density of the atmosphere is getting less and less and less and less. So the moon is essentially in some very rarefied environment and is a solid. Do we know of any solids that are not as dense as rarefied air?
Mate, again, you're basically trying to strawman my postulation anyway. You know, just because I'm saying relative density works here on Earth for things, okay, does not mean that I am basically saying to you that there isn't another thing that is either keeping the moon where it is, allowing it to do what it does. I'm not making the claim, am I? I'm not saying there isn't.
That's cool. Then we can stick with the hypothesis that's in place right now until you come up with one. And the hypothesis that works really good is gravity. Actually, the theory that's been proven out by many experiments is and borne out by evidence is in keeping with it, and it works. So we can stick with that, and we'll leave it open to it. Someday we can find out that there's fairy farts that hold it up. But right now, the best deduction we can make is gravity. End of story, isn't it?
Yeah. Well done, mate. You can keep saying gravity. That's cool. Like that's fine. Like I said, I'm actually happier with the way you guys, the nice guy explained it. You guys explained it. You know, some people try and say they understand the full cause and effect relationship. That's fine. You're just naming phenomena that you see, and you're calling it gravity. Basically, to me, that just means you're using the word gravity to explain all of the effects that you don't understand.
Not true.
Why they exist? Yeah, no, it is.
Straw manning.
Yeah. Well, guess why? All right. Well, gravity 2 is why my shit's up there. The mathematics for it are as follows, the same as yours. We can predict stuff with it. Okay.
Well, once you
do it, so you can predict. You can predict. So, like, listen, you can predict the ancient society. Literally, ancient cultures literally predicted. You know, a lot of the same things when it comes to the heavenly bodies and stars and all this shit. They predicted many of the same things without gravity. All right.
Didn't they do that with just timing? They just they did that with a calendar essentially. But the defect in calendar methods is we can put something up tomorrow, and without a calendar, we can know that it will work. And we can see something flying around getting captured in an orbit. We can tell you what's going to happen with it. So it's not a matter of, you know, calendar predictions necessarily. We can make predictions to the second of the phases of the moon, of eclipses, but we also can make predictions of new observations that haven't been on a calendar.
Cool. Like the comet Neo was, right? But they didn't know that was coming, but
they didn't know it was coming, but they knew what it was going to do after it got to a certain point.
That's kind of like the Mayans, though, right? They would have seen it, and then they were like, "Oh, right, now we can say when it's coming next time." Like they did with the eclipse.
No, not necessarily. You have to see it twice in order to start forming a pattern.
Right. So
we can do it once.
That's what you said they could predict it before, though.
Now we can do it. They could. The Mayans couldn't. That's why it took a long time to start predicting eclipses and stuff. They had to find a pattern. That took many
We
observations,
don't really know their full methods. There are certain methods that say that they used like certain stones that obviously they built up to certain altitudes, and like they would look through and wait for parts of what they would call the sky clock, right, to align through slots that they had chiseled out and stuff like this. Incongruity to a calendar, obviously, like using it in conjunction, with a calendar.
If I may weigh in very slightly, we know very little about how the Mayans did what they did.
Yeah, that's all.
Or even the conclusions to it, considering we have really only deciphered a very small amount of the written language that's available to us, and there isn't that much of it as well, because most of it was destroyed by the Catholics.
Yeah, no, I agree. Actually, like that's all I know about what they were able to do, and even that could be bullshit as far as I'm concerned.
It's archaeological interpretation.
Yeah.
So that's
yeah, exactly. It's so open to interpretation, isn't it? Like, oh wait, you're fucking yes, my man, Jamaica.
Hey,
Jamaica. I just recognise your voice. I'm not even looking at the fucking screen then, and I recognise your voice as well. Fucking mad, mate. How are you? You right, mate?
Yeah, not bad.
Oh, good.
Busy day so far. I've decided to take a 30-minute break. So I haven't even had lunch yet.
Taking a sabbatical from the busy day.
Right.
Fucking right, mate.
6 conference calls down. 1 left to go.
1 left to go. Then back to pub that closes at fucking 10 o'clock.
I don't drink, so I'm no problem there.
Yeah, lad. What's with all tits and this and giving over the ear?
Wait, you fucking whole lad like towel, like tits off. You get your tits off and go to pub, like.
Cal don't go to pub. Cal goes down to sliders.
Mate, what 1v1? Do you come in here a lot, like with these 1v1 reading your shit, like fucking hell, mate.
Wouldn't catch Snick if you was sat on gate, lad.
Mate, honestly, you Hullians and Sheffieldians, mate. You're all mental as well, mate, honestly. I've never met anyone sane from Sheffield or Hull.
Yeah, I'm far from sane, me, yeah. You met another fucking nutcase there you got.
I'll tell you what, the girls in Hull are very friendly in my experience.
Friendly?
We're going to head back to your room because this seems to be now just a general conversation.
Yes, but the second you leave, we're going to start exploring the depths of, trying to allay my flat Earth skepticism, and you'll miss it.
I agree.
Stick around, Witchett's about to come in.
I hope Crackvillan, like we did fair with you regarding the Cavendish and other things, I hope you take them in consideration, try to revise them, research them a little bit more. Like honestly, like you see, like there's a reason why the whole entire planet, knows that the Earth is globe, and we do a lot of experiments and missions to the space. It can't be just a conspiracy, my friend. Please take that in consideration. It's too much for it to be a lie. It's just too much. Humans can't keep a lie.
What do you mean the whole planet knows that it's a sphere? That's not true.
The whole planet looked at a popcorn now. Okay, go ahead. What do you want to say?
Did you actually just attack me? Your first words to me were calling me a F.
Are you saying China and Russia are all conspiratizing? Are you saying Russia and China and the United Kingdom? Are you saying all people are lying to us?
Guys, can we stop? Sorry,
are you saying
guys, can you stop over talking each other? Stop it.
I heard your question. You don't have to say it 5 times. I heard it the first time, and I heard it every time you said it while I was trying to answer. Your claim was that the whole planet, which is asserting that it's a planet in the first place, and the whole meaning that all the planet, everyone on it, knows that it's a sphere. Now that is a false claim. It only takes one, right? And I'm one, to prove you wrong. I don't think it's a sphere. So the whole planet, is your assertion, doesn't think it's a sphere.
No, very crazy. Well done.
Sphere either. Thank you. Your claim is baseless.
That's a fair point. That's why making absolute statements about things is pretty
Yeah,
silly.
but Rakia just fucking joined recently. I was trying to talk with the other guy, Crackvillan, whatever his name is. Try to give him the idea that it's too much for the whole world to be conspiracizing on you.
Listen,
to tell you that it's a lie. China, Russia, UK, Japan, UAE, India, they can't be all in the fucking same hand. They're trying to lie on people and deceive them into we are actually a flat
Nice guy.
earth
Can
and
I
there's
just
no
steal
space.
man
It's
your
too much.
argument very quickly on a really simple point? If India's space mission was fake and Pakistan knew it, what would be the next thing? That's the point that he's making.
Well, I don't understand the whole thing about if anyone believes you're wrong, if one person believes you're wrong, that means you have to be wrong? That doesn't make sense.
No. He made an absolute statement saying everybody on Earth knows it's a sphere.
Yeah.
Which is an absolute
statement.
Okay,
so if one person disagrees,
then
sure.
that statement isn't true.
But now, on the other hand, if most of the people believe that it is, what would it take to make you convinced that they're wrong?
But it's not that most people are convinced.
I'm asking him. Yeah. I'm asking him. Yeah, I'm saying. On the other hand, if we flip that around, most people do believe that it is a sphere. So, what would it take to make you believe that it was flat? What's the evidence that disproves the general consensus?
Consensus for him, wouldn't it be? It would be everyone else believing in it being flat, and then he would believe it's flat. As he stated.
You mean round?
Majority. Appeal to majority.
Yeah,
okay.
and that's why I wanted to sidestep that question, because that question is pointless. The better question to ask is, why do most people think it's a sphere?
Well, I think too that his experience is.
I can answer that.
And he don't.
All right, David, answer that. Why do most people think it's a sphere?
Because that's what they're taught, and they don't look into it.
Yeah, that's an easy answer. Do you think most people are that stupid?
No.
Do you think most people just believe?
No, I just think it doesn't really.
In general, I think they just don't think about it, just like I did. I just went through life not thinking about it. I was just taught that and told by my authorities, and I trusted that. I had no reason to question it.
No, that's the same way. That's the same way that
are outliers. No, you guys are outliers as well, because you actually are looking at it. You're not like normal everyday people. Most people don't give a fucking shit about the sphere Earth. They've never actually evaluated any of the evidence.
Nothing.
Anyway,
I never knew there were alternative theories to any of it, right? Gravity, the sphere, the shape, the way things were. I never knew there was even an alternative theory until I started hearing about it and thinking about it and applying what I know, and then going out and testing it myself.
So then we look at weight. That's the next criteria I normally move to. So what's the weight of the evidence for one proposition versus another? And I don't think it's unfair to say that the weight of the evidence that we have available to us confirms the fact that the Earth is a sphere, it rotates, we are in a heliocentric model.
I agree with
Space is out there, and we can send probes out.
I agree with the consensus of the mainstream, authoritative, proof or whatever. Who's giving the evidence? Who's writing the textbooks? Who's controlling the sources of media, which is where we get our information from mostly. Yeah, I think their consensus that it's definitely a sphere and definitely everything is settled basically. When you get into the alternative and you start investigating it yourself, which is what you should do, not just trust other men, go out and actually test these theories, then it's quite evident that things are amiss.
But the point I want to make, I mean, I don't tend to rely on the media if I want anything depth. If I want, it's a bright, sparkly kitty and it can do a backflip, cool. That's kind of the depth or the seriousness that most of the media that we look at goes into it. It's a very, very top level, slim view.
I think
for me, I like to go. Yeah, I like to go back to the actual data.
Right,
ancient
but even
alien.
that data, that data is controlled by the controlling authorities of the day who, started writing the textbooks for the schools and for the
not really.
system.
You see, I would disagree with that because as soon as you move into college and university education, I'd agree. When you're at high school, you kind of, this is the way the world is. Go for it. Here's some stuff on critical thinking. Yeah, that's all cool. When you get to the sort of the college university level, then that remit kind of drastically changes. And now what you're doing
who writes
is you're
those
going
textbooks?
You're not doing stuff from rote off textbooks in a university.
Sure you are.
No, you're not.
Are you kidding me?
No, I'm not kidding you.
Okay, I went to university. You had textbooks for every class.
Yeah, but you're testing those textbooks, aren't you? You're validating them.
No, not really.
No, you're learning what's in them. You're being explained how the formulas work, and you're taking tests based on it.
Yeah. What did you study at university?
I first went into chemistry and was going to be a dentist, so I took biology and chemistry, a little bit of physics, and then I started into finance and accounting and ended up in business management.
So let's take chemistry. So when you were doing chemistry, you would have learnt about covalent bonds between molecules. You would have then started to work out how to break down those bonds.
And the main lecture was from a textbook, and then we had
labs.
Then
you go and test them in labs.
Yeah,
that's how it works here. Yeah,
right. But it was mainly textbook.
But you are still doing practical tests, are you not?
Sure, absolutely, yeah.
Yeah. So that's where you're doing the empirical validation of those precepts.
Because, exactly, and that's my point. When you read in a textbook that gravity causes water to bend around a sphere, then you should go out and empirically test that by doing measurements of that so-called bendy water.
And I provided a measurement that was taken showing bendy water, which everybody wants to hand wave away.
Which would be from what?
I can post it if you want.
Yeah, sure, but just explain it to me in short layman's term. Was it a drop from horizontal made up by?
No, it was left to right because that.
Right, exactly. Yeah, there you go.
So that seemed to be what people wanted to see, and there it is, the horizon of matter.
So let me know where you posted it.
I've posted it in the main debate chat box.
Yeah. So for years we've been told you can't see in any way possible left or right curvature, right?
No, we haven't been told that for years. That's an anecdote that you want to take from a comical skit that Neil deGrasse Tyson did, right here.
Okay, well go ahead. Then you explain it. Above what Neil deGrasse Tyson told us, the astrophysicist, we'll let you explain what you posted. Explain to us what that is.
What you've got there is you've got two guides, which are parallel, straight lines.
How do you know that?
And then because I've actually looked at that image and I've tested it, and I know the person that took the image, and I'm happy with the results that he did.
Wait.
And again, that's saying, how do you know that is a hand waving away, Rakia, rather than exploring?
No, I have a question.
Looking for an excuse to dismiss.
No, I'm asking you a question very simply. That's a photograph, a picture of water?
Yeah.
Taken by a lens?
Yeah. And if there's any barrel distortion in the lens, wait, because we accounted for this, and when we discussed the experiment, he accounted for that because the barrel distortion would affect all objects in the view of the lens. And what we're seeing with this, with a nice lens that doesn't induce much barrel distortion, is that that's not being affected, because otherwise it would affect the curve on the actual guides themselves as well as the water. They would be symmetrical to each other. They're not. That shows that we can discount barrel distortion. Next.
It was an anamorphic lens?
I'm not sure the exact lens he used, Mr. Reality, and I'm not going to sit here and pretend I know things I don't. But barrel distortion was one of the concerns brought up when we were discussing this as an experiment.
Right. We'll let you go with that one I don't know. Keep going, because I've never seen this explanation.
So if you actually open the original and pop it into a browser, you can then see quite clearly that from left to right, we're seeing different heights and elevation in our guide.
Okay. So you're saying the left side... I mean, okay. So you're saying the left side is higher than the right side?
Mm-hmm.
You also said
Well,
you just had to drop it out.
That's not how a drop works. That's slope, sir. That's not curvature.
That's a
You don't
curve.
have drop.
No, that's slope.
That is a curve.
It would be equal on both
That
sides,
is
wouldn't it?
slope. It would be equal. It would be higher in the middle.
And if you've got a curve, would it not be higher in the middle from this type of observation?
And lower on each side.
Yeah.
You have a slope. You have it high on the left side and low on the right side. That's a slope, not a curve.
No. We're going across the entire apparatus. So just from one side on the left. If you look at the guideline on the left,
you
it's clear.
got a slope. You got an uneven camera or uneven. You got your parallel bars that a man put on a table out in the environment is not level. Yeah.
What are we looking at?
You got a camera that's crooked, or you got two parallel bars that aren't parallel. Yeah. You don't have a curve there. You have a slope.
That to me is hand waving away.
No, you have a slope. You're showing me a slope.
You threw the trash away, Druss.
You're showing me a slope here and saying it's curve. It's not. It's a slope.
Okay, so I have another image I can provide that shows curve.
So we're dismissing this one.
No. Same image, just a different way of viewing it.
Anything tangible, Druss. Anything tangible, we could,
How am I going to give you something fucking tangible on Discord, you idiot, Jeremy? Sorry, that was a stupid question.
Do you have a tangible measurement?
Give me something I can use.
You have a tangible measurement that you took. No long range optical things where you can have all kinds of light bending and different things happening.
Refraction through the lens.
Garbage.
That thing doesn't prove anything anyway. That image doesn't, I'll be honest, mate.
You got something tangible or you got trash, Dross?
Yeah, it's just
straight trash.
It's a bad image.
So now you're
The
compressing a
Goldbergs have
photo.
not proved
Now you're compressing a photo, which is worse. So you might
Where
want to
did
go
you
back
get
to
that
the first
photo from? 1v1.
More garbage.
That's the work that MC Toon did.
Why are you
I
limiting?
wouldn't use that. I wouldn't use that, dude. He's used a form of compression, mate.
Yeah. This isn't your
which is great because what the compression does is it shows a very slight curve and it exaggerates
No, it doesn't.
So without that curve being there, sorry, if I can finish a sentence without being interrupted. So if that curve wasn't there, it wouldn't be shown in the compression.
David, what is a Fresnel lens do? What does a Fresnel lens? What does that do? Do you know what that does? It focuses.
It causes concentration, right?
It focuses. Yeah, it focuses all the points of light into a single focal point.
Yep, and the light of the actual water is coming from further back, unfortunately, and this is the issue with it. With this compression of these images is that basically that's not from MC2. That's from someone called Rory, apparently.
Well, no. The problem with using a Fresnel lens to try and demonstrate that the atmosphere is a lens is that it doesn't act that way at all.
You mean a Fresnel lens?
Yeah, Fresnel. Sure. Fresnel, sure.
Any lens, really.
Not any lens. Not any lens. A Fresnel or Fresnel lens is a very specific lens that focuses.
I know that.
Okay. Well, it focuses all the light to a certain focal point. So that's not. So when you do that experiment to show how, like, oh look, the sun goes away, it gets smaller, it gets bigger. That's not very. That's very disingenuous.
Wouldn't it be more and more like that, depending on the layers that it's going through, though? Like, depending on how far away the layers are and how they stack up or whatever?
Atmospheric lensing.
Well, yeah, there is an atmospheric lensing effect, but it's not going to be like a Fresnel or Fresnel. I'm sorry, whatever you call it, a Fresnel lens. Is what
it doesn't matter. We know what you're trying to say, dude. It's cool.
Yeah.
I'm a pedantic person with language, so I apologize, Monkey.
Yeah.
No, you get.
But in the meantime, though, Druss, you got no proof Waters curve, and you got no tangible measurement at all. You got trash.
Well, that's a lovely opinion, Jeremy, without any of substance. So well done for doing that.
Yeah, 1v1. Can I make a comment on that?
Sure.
So like the issue is like obviously the light that's reflecting from the actual sea itself. Would you say that that curve adheres to the curve that you would expect to see from the Earth?
Well, funny enough.
Well, it's not my opinion.
I thought we were going to ask that, so I put in the Excel spreadsheet of the data where we've done a number.
If you're saying yeah, then that's fine.
Yeah, it's not my opinion. You don't.
I posted the evidence at 7:54 minutes past the hour.
It's not my opinion. You don't have anything tangible. You don't.
Nice opinion, Jeremy.
One of the
sticks. Opinion. You don't have a physical tangible measurement. That's not my opinion. That's a fact.
Jeremy, let me just. One of the sticks appears to be higher than the other one, obviously, right? Okay. Also, right. This is obviously due to the way the compression works. You can see the little light flare, right? That's obviously the water is appearing higher on that side than the other side. What I'd say is the light that's reflecting. Obviously, we know the way cameras work. You know, they take in light and they interpret the data in the form of photons onto the sensor, right? The issue with this is that with compression of this obviously this horizon in the background is, I believe, the reason why it's on the right side. I believe why it's arcing up more is due to the way the light is in this shot. There's obviously some form of bias on the right side with the light.
When we plot that onto Excel, which is what I did in the second image there, it conforms to, it's reasonably accurate to the size of the Earth. And the second thing, that then is in concordance with other observations we made, like a multi-point Aristophanes experiment or an Al-Biruni experiment. We all seem to be heading towards this similar sort of size, plus or minus a few percent.
But he's right about the angle of the light, because when you have that, the light, when it hits the atmosphere at a certain angle, it can cause an artificial, like, shadowing and brightening of a certain area. So all of a sudden you don't see the water surface.
All photos, including your black swan?
Hear me out.
Oh no, that's not the argument.
Give us something tangible, man. Give us a tangible measurement. None of this long range optical trash.
Yeah, that's 54 minutes past the hour.
Where the reality trying to say something.
Sorry, reality. I interrupted you. I apologize.
No, I was just saying, because I've seen this before in Nicaragua. I was 15 feet off the water surface on a patio looking out at the surf, and all of a sudden the atmosphere changed a little bit, the environment, and all of a sudden I noticed that it was sloping. It was causing an artificial, like, curve close to me. No longer was the horizon further out, it was closer, but also caused there to be curve on the edge of the left right side of my sensor when I looked at the footage. So all of a sudden I couldn't see any further of the water surface, because all of a sudden the atmosphere became like a wall, and I couldn't tell between it being curvature or just being the atmosphere. It just caused like an illusion.
I like that point a lot. See, that's a point with substance, Jeremy. Okay?
Yeah, my point is you have nothing tangible. Hold on, Dross. My point is, this is my point. You have nothing tangible. It's all optical.
No, I posted evidence. I posted the tangible evidence, Jeremy.
Your shit is trash. You have no tangible measurement.
Shut the fuck up and stop being annoying.
Trash,
you're obviously triggered. I'm guessing your polishing machine for the floor is not working today. But what I'm trying to say here is at 54 minutes past the hour, I posted the tangible data. What have you got a problem with that data?
Tangible measurement.
Yes, no, the tangible measurement. Yes.
Physical, physical, tangible measurement.
Yes, they're there 54 minutes past the hour. Have you looked at that image? Of course you fucking haven't, because you never do. That's why I'm annoyed with Jeremy.
54 minutes past the hour.
Yeah, so I'd really like to address reality's point, because I actually think it's a good one. That's a point with substance. That's what I was trying to show you. So I want to address his point, because he was kind of ahead of you in the queue here. You're just shouting dismissive statements without any content. So that's cool for you. So the point that Mr. Reality made that I thought was interesting was he's made an observation where he's seen something like this occur. And again, we can talk about the barrel distortion, the atmospherics, etc. The thing I liked about that test, and I think that test can be done way fucking better, to be honest.
Shit.
Yeah, and I'm agreeing with you that it can be done way better. And I actually think that's an interesting test to repeat multiple times in multiple places to see if we get something consistent coming out.
Okay,
why did you present it? Hang on. Why did you present it as your proof?
I presented it as an indicator, not as absolute proof, Rakia. We've had that conversation.
I asked you. We were talking about proof, and you said I have curvature left or right. Let me post it.
Yeah, it certainly seems to indicate that. So I've got a rock. I've got a call coming.
Okay,
Oh no.
yeah. See you later.
No, I'm still here.
1154. You posted a graph. That's your tangible measurement of Earth curve.
Yeah. How else? Okay, Jeremy. What do you want me to give you?
Something non-optical.
Yeah.
Optical, non-long range optical.
That's not a long range optical.
Long range optical trash where.
So we ignore. Okay, so Jeremy, don't ever present.
Reality just exposed you.
No, Jeremy, don't ever present a picture to me again. Don't ever use a picture in any form as evidence. Okay, if that's your excuse, are we agreed?
All you have is long range optical.
No. Are we agreed that you're not going to present photographic evidence
if you don't have
anymore,
a tangible measurement,
and you're not going to try and talk about the black swan
if you don't have a tangible measurement of Earth curve, you got nothing. You have no proof.
And that is a tangible measurement of Earth curve.
What is it?
That graph is a tangible measure of Earth curve. That's taken from the photographic data.
That's slow.
Is a tangible measurement of Earth curve? You know how stupid that sounds?
Oh, Jeremy.
You know that's slow.
Tangible measurement of Earth curve.
Yeah. Can I get a view from, because I don't want to straw man Jeremy here. Mr. Reality, Rakia, Crackvillan. Am I being unreasonable here?
No, you're not being unreasonable, mate. Like,
the graph is a tangible measurement of Earth curve.
What's the graph represent? What's the data?
What the
data
graph
on the graph?
Basically, what it is, it's a pixel count taken from multiple. Yeah, so it's a pixel count. So
what's a pixel count?
So it's the pixel height going across the image, and then we've plotted that as an arc.
Yeah.
And then we've seen how that arc confirms to other indicators of the size of the Earth.
Gosh, you're supposed to be smart. You really think a graph, a piece of paper, a picture on a screen is a tangible measurement of Earth
if I
curve?
write down the numbers, is that a tangible measurement for you, Jeremy? How do you want a tangible measurement? Explain to me.
I explained it to you multiple times.
A tangible measurement.
It's something that doesn't involve long-range optics. It's something that's tangible.
Cool. So the black swan. So I just want to finish this point. So you're now saying the black swan is a crap image, then?
Cool.
The black swan is the reason why we need this tangible.
He wants a tape measure. That's like the only thing he'll accept. It's like a tape measure or something. It's fucking stupid.
Yeah, tape measure. That's what I want.
Right.
Is that seriously what you want? Sorry,
right. So you're not being unreasonable at all, but obviously, some of the things you're claiming about these pieces of information are not obviously in.
I have over pie. Put it that way. I shouldn't have been as hard and say this is absolute. No, I'm not saying this is absolute. This is absolute certainty. What I'm saying is this is a really good indicator that seems to correlate with other observations.
Right.
So the issue with this is why I'm giving it weight.
What's the distance from left to right of that horizontal line?
I can't remember. I've got the stats somewhere.
Jeremy, with all your tangible measurements, you come up with the fishing. You come up with the fishing line experiment, and you've come. I forget the straight line experiment. But the problem is with all of those tangible experiments, there are things that are confounding factors which make them not tangible. They're over long distance. You can't verify that your tests are set up properly. So no matter what, even your tangible experiments are just as flawed as the.
I would say the black swan holds more weight than this.
Well, I still think the proposition I'm putting forward that is we do this test better in multiple locations. What's people's thoughts on that? Seriously.
Well, you could do it, but I'll say something to you right now. You say this is a bad example. I honestly do not believe you'll get much better of an example. Like, I would actually be willing to do it for you. I would be willing to do it for you.
I think the concept was really sound, because what we've got is we've got a fixed guide, and then we can compare against the guide, and that's what I liked about it as an idea.
Next time they'll do it so the sun's just right and it makes it look like it's curving evenly on both sides. They'll fix it just right. And
are you accusing us of making shit?
No, he's poisoning the well before anything's ever even done, which is
the
just
thing
a very,
is,
very
though,
sad standard.
this could be a reification fallacy, because obviously the issue is with it is that just with compression of images and the way that lenses essentially are spherical in nature, but not spheres. Obviously, we know that they adhere to a convex,
convex concave,
shape.
depending on the type of lens you're looking at. Yeah.